Okay, I think we're recording. Hey everyone. So this is our last video lesson of the course. Yay! And let me get to my thing. There it is. So what we're going to talk about is applications of the indefinite integral. And remember, the indefinite integral is something from, let's do something more interesting. From 2 to 6 of 2x minus 7 dx. So 2x minus 7, the integral of 2x would be 2x squared over 2 minus 7x, all evaluated from 2 to 6. And so we would do, the 2's will cancel, 6 squared minus 7 times 6 minus 2 squared minus 7 times 2. 6 squared is 36. 6 times 7 is 42. It's always important to keep them in parentheses so that you don't miss the negative sign error that might happen if you get rid of these parentheses. 36 minus 42 is minus 6. 4 minus 14 is minus 10, so that'll become a plus. That'll be 4. So anyway, that's an indefinite integral. I mean, a definite integral, because you have these limits that make it definite. There's no integration constant out here, because we have these things that are telling us where we're integrating. And this is the area under this. Where's my thing? There it is. It's the area under this. That is a line, has a slope of 2, a y-intercept of -7. So it goes up like that. And we just found the area from 2 to 6, something like that. And we have this positive area and this negative area. And we add all that stuff up and we got an area of 4. That's what we just did. But we are going to do business applications because this is a business class. And the first one, so this is chapter 13.4. First one we're going to do, goodbye Olive Garden. Oh, you can't see that, can you? I got an email from Olive Garden. How exciting. Continuous income streams. So this is like if you buy a gas station or something, how much income comes in. And problems will say if something, f of t, is the rate of the flow of income. What does rate mean? What does rate mean? Think about it. Right, rate means a derivative. So f of t is a derivative, and if we take, as you recall, if we have y equals f of x, if we take the integral of the derivative, we get the original function back. That's why this is called the antiderivative. So we will, let's get rid of u. Oh, I can do Control X. Let me try that. Oh, look at that. Okay. So if I take, let's see, we use, if I want to know the total income from this flow of money, I'm going to integrate it from some time value to some new time value. That's supposed to be a 2. Okay? This is going to be our equation. Oops. It's an equation. It's important. So we are going to go colored. This is the equation for total income, that you take your rate and you take the integral of it. Okay? Okay, so for example, let's get a new page. Don't save. No. Okay. If a rate of income is 600 e to the minus 0.2 t. Okay? This is how much rate is coming in per day. This is how much money is coming in per day. And what we want to know is what's the total income over 10 years. Okay? So, total income is going to be the integral of 600 e to the minus 0.2 t dt from 0 to 10. We need to be really careful and make sure we know, is this the amount of money coming in per year or per month? If it's per month, then I don't want to do 0 to 10 years. I would do 0 to 120 months. So it's very important we look at the units on a problem. This is in years, so we're okay. Okay, so to do this integral, I'm going to pull the 600 out because it's just a coefficient. So this is e to the minus 0.2, 0.2 t dt. So this is an e to the u problem. And what's the integral of e to the u du? Right, e to the u. So I need to do my du little dance here. So I'm going to let u equals minus 0.2 t. And then du will equal minus 0.2 dt. Do we have minus 0.2 dt? No, we got the dt. We don't have the minus 0.2. So I'm going to multiply it in, minus 0.2, and I'm going to divide it away as also. So that all I've done is effectively multiplied by 1. So now I can rewrite this as 600 over minus 0.2. We'll calculate that later. From 0 to 10, e to the u du. Now we're matching this pattern, so I can apply the rule. 600 over minus 0.2 e to the u, evaluated from 0 to 10. Now I do my substitution. Well, first, what's 600 over 0.2? It's minus 3,000. Okay, so now I'm going to plug this back in, and this will be e to the minus 0.2 t, evaluated from 0 to 10. Whoops. Okay, so this is going to be minus 3,000 times e to the minus 0.2 times 10 minus e to the minus 0.2 times 0, like 0. So equals minus 3,000 e to the minus 2 minus e to the 0 is 1. So now we can crunch this number, and whatever that comes out to be, comes out to be. Okay? Does that make sense? That's all of total income, is you take the rate of income flow, check the units, check the units, check the units. Because if this is in months, then the limits have to be in months. If this is in days, the limits have to be in days. So check the units. So we take the rate of income and we integrate over the time that they give us. Here they said over 10 years. They might say, we want to know the total income from year 6 to year 9. And so they'll do that. This is something you would do if you have a business, let's say, and you want to sell your business. So you would look at the income over the last 10 years. No, you'd probably look at the income over the next 10 years and use that to look at the valuation of your business, because that's what you want the sales price to be. You don't want to sell your business based on how much it's worth today, because it's going to continue to earn income. And that's why somebody wants to buy it, is because of the income earning potential. So you would do this calculation for the total income you would generate from your business through the future, and that's how you would evaluate it. And I'm sure there's some standard number of years you do the evaluation over. I have no idea what that is, but that's probably what you would do. Okay. So let's stop there, and I'm just going to do another video for the next one, because we have 3 different problems to do. So I'll make 3 videos. Okay. Bye-bye.